Hey guys, so this is our third lesson on chapter 6, which is dealing with linear systems. So we've seen quite a few questions where we're solving for an x term, and we have to use either the multiplication principle or the addition principle, or sometimes both principles. We've also looked at using some different techniques for solving, and so one of those was multiplying by the reciprocal. And it's a very useful technique when the questions get quite large. There's lots of fractions or perhaps decimal numbers, or maybe both decimals and fractions. So if you can multiply through by the LCD, then what will wind up happening is we'll just be dealing with integer values. And it's usually much easier to handle than fractions and decimals and everything kind of combined in one. So I would encourage you to try some of the questions we've done using this technique. It's used quite a bit in Math 11 and 12, but may be new to most of you at your age right now. So I would encourage you to give it a try. So today we're going to be looking at linear inequalities. It's not a very big lesson, and I think some of you might have done some of this already, but we're going to sort of start from ground zero as if you haven't. So I'm just going to switch over and share my screen with you, and we'll go to my notebook here. Okay, so here we go. So we have a really interesting picture on the left here. And we have, oops, you know that. And I'm gonna turn my video off here. I don't like having that going on. There we go. Okay, so we can see on the screen there's this tall person here and a smaller person, and one's wearing blue and one's wearing yellow. So we're going to say that B is the person wearing the blue shirt, and Y is the person wearing the yellow shirt. And then we have three statements here. I'd like you to read through them and decide whether they're true or false statements. Just write a letter F or letter T if you think they're true or false. So I'll give you maybe just a minute to do this. Let me just pause the video. Okay, so the first statement says the height of the person in the blue shirt is not equal to the height of the person in the yellow shirt. So I would say that their heights are different. So I think that's a true statement. They're not equal to each other. So that would be true. You would agree with that? The second statement says the height of the person in the yellow shirt is less than the height of the person in the blue shirt. Well, I think the person in the yellow shirt is taller. I guess if I look at the picture at an angle, no, that's not going to work. So no, the person in the yellow shirt is taller than the person in the blue shirt. So I would say that that statement is actually a false statement. Now to correct it, what we could do, I guess, is either we could switch the position of yellow and blue, or we could reword it. So instead of saying less than, we could say greater than. Maybe the height of the person in the yellow shirt is greater than the height of the person in the blue shirt. Okay, so the third statement says the height of the person in the blue shirt is less than the height of the person in the yellow shirt. So I think that would be true then, because that's kind of like the second one, just switching the names here of the two people. So I would say that is also, oopsie, true. So hopefully that kind of makes sense here. So the math we're doing now is more on these kinds of statements where we use words like not equal to, less than, greater than. So I want to pause the video again maybe and just see if you can put the symbols down beside these 5 examples. So these 5 examples here. And maybe write an example of what the symbol could be used for. So once again, just pause the video and see if you can do that on your own. Okay, so the symbol not equal to would be an equal sign with a line through it. That means not equal to. And an example of that, if I was doing a math question, I guess I could say the number 5 is not equal to basically any other number that's not 5. So maybe not equal to 10. I think that would be true to say. So 5 does not equal 10. Now, in the word math here, we use less than sometimes, and that symbol can be confused. I know there's lots of different ways to explain this, but generally less than looks like that. That's our symbol here. Sometimes people draw like weird Pac-Man shapes and stuff like that with like giant razor sharp teeth. to explain what the symbol is doing, and they would say if it's facing that way, it's eating in that direction, so it's getting bigger. It's getting bigger on the number line. But I don't know if I like that. I know they also have like um, Pac-Man, Pac-Woman, and that's good too. And I'm sure we could create a whole bunch of different characters if we wanted to. So I guess we could say that if we use the numbers 5 and 10, we could say 5 is a number that is less than 10. I think that would be true. That would be a true statement. Now greater than is just flipped the other way, so it's bigger, like that. So a number is bigger. So I guess I could say the number 7 is bigger than the number 4. I think that would be true. And then less than or equal to and greater than or equal to, they're just the same symbols above. It's just you include the equal sign here. So greater than or equal to. So kind of like that. Now, if I said, if I go to the example above and I said 5 is less than or equal to 10, that is true. 5 is less than or equal to 10. But what if I wrote this? What if I said 5 is less than or equal to 5? Would that be true or false? Because I know it wouldn't be true if I did it up here. If I wrote 5 is less, sorry, 5 is less than 5. Well, that doesn't make sense. 5 is 5. So I would say that's not true. But if you have the equal sign, it's actually still a true statement because the number 5 is equal to 5, and the statement says less than or equal to. So the or means it could be one or the other. And so the example below would be greater than, so or equal to. So I could say 15 is greater than or equal to 8. So that's a number that's bigger than 8. And of course, 15 would also equal 15 if I didn't want it to go that high. Okay, so let's write 3 examples. So using the 3 examples above, let's see if we can write statements. So I'm going to use these examples here, these word examples, and translate them into mathematical inequality statements, but using maybe the letters B and Y. So I'm not writing all the words out here. Okay, so the first statement said the height of the person in the blue shirt is not equal to the height of the person in the yellow shirt. So I guess I could say the height of the person in the blue shirt is B, and B is not equal to the height of the person in the yellow shirt. And so we'll say these letters refer to the heights of those people. The height of the person in the blue shirt is not equal to the height of the person in the yellow shirt. Now, if I was to write the second statement, even though it's false, if I wrote it, it would be the height of the person in the yellow shirt is less than the height of the person in the blue shirt. Now, we actually said that was untrue, but that's how it would be written if it was true. So if it was a true statement, you'd write it that way. Now, there is another statement you could write. You don't have to learn this. It's not part of our lesson. But if this is untrue, you can just draw a line through it, actually, like that, just like the not equal to sign. And now what you'd be saying is y is not less than b. But we're not going to give you too many symbols, so I'm going to erase that one. Get rid of that. But if you go into higher level math, you'll see those symbols in some books, and they sort of treat them the same way as the not equal to sign. So I'm going to scribble that one out. I'm going to say this here is actually not a true statement, but it is actually the correct way of how to write that. And the third statement here was the blue shirt, the person in the blue shirt is less than, the height is less than the person in the yellow shirt. And that is true, actually. Okay, so that's just a little bit of how to use the symbols here. And what I want to talk about also is how to write this on a number line. So let's say you had a statement that was, I'll write 3 statements here. So let's say you said x is bigger than or equal to 2, or x is less than 5. Let's make it -5, less than -5. And let's say we said that x is bigger than -1 here. Okay, so this is kind of like the questions we did yesterday, where x could really be a multitude of numbers here. Unlike in the equations, it could most times you saw just one number. You've got one solution here. There's many answers that would be true here. So for the first one, x is a number bigger than or equal to 2. So, I mean, 3 would work, 4 would work, 5 would work, 10 would work, 15 would work. I mean, there's so many numbers you could pick here. You just couldn't pick numbers that are less than 2. So when we draw this on a number line, we sometimes sketch the line like this, and we put a little dash there. And that dash is the number that's in the question. So in this question is 2. So we put a 2 there. And so now we have to sort of show how we would decide where to shade here. And so we're going to say that we can be at 2. So we can be at 2. Or we can be any number that's bigger than. So that would be to the right of 2. So for the next one, we would say that x is less than -5. So I just draw my number line, put a dash here, put -5 in as the magic number here. Now with this one, I know that it's less than, so that would be numbers that are smaller than -5. So -6, -8, -10, -100, -1,334,522. The only problem is I can't be -5. There's no equal to sign here. So if there's no equal sign, we use an open circle like that. Whereas in the question before, we used a closed circle. We sort of shaded it in there. So the open circle means you can't be at -5, but you can be any number that is smaller than -5. And so for the last one here, if you want to pause the video and try it yourself, see what you think. So we're going to put a -1 here. And now, do we use open circle or closed circle? Like, would we shade the point in or not point in? Well, there's no equal to sign here, so we can't be at -1, so we'll leave that open. And then we're going to shade everything that is bigger than -1. So that would be anything to the right there. So that's kind of how we draw a graph, an inequality on a number line, and show the value of it. So I'm just going to see if I can do one more example in this area before I move on to the word type problems. Okay, so let's say you had a statement like x minus 4 is bigger than or equal to, say 6. Say 6 here, okay? And you were asked a question like, which of these numbers would make this true? -6, 0, 5, 11, and 12. So the question is, which of these 5 numbers are true for this statement? Actually, it actually makes the statement true. Well, what I would do probably is isolate x here and see if I can get just a separation of the x values in the numbers. So I'm going to add 4 to both sides. I'm going to use my addition property. So that is, if I add 5 to both sides, it should still be true. And I get x equals, I should say bigger than or equal to 6 plus 5, which is 11. Okay. Now, if I draw this on a number line, if I want to sketch this to sort of get a visual aid of this, I put a little line here at 11. And I would say that I could be at 11 because I have an equal sign, and I'm bigger than or equal to. So I'm allowed to use any number that is 11 or bigger than. So what numbers would not work, first of all? Well, -6 would not work. That's too small. That's in below 11. 0 would not work. 5 would not work. But 11 would work, and 12 would work. So the 2 numbers that would work in this case would be 11 and 12, but the other 3 numbers would not be true. You could plug them in here at the very beginning statement, but then you have to -4 from each one of those. I think it's much easier once you graph it. You can easily see which numbers are not in that group. But there are other ways to do the question. That's sort of up to you to decide how you want to do it. Okay, so I'm going to move on to translating inequality statements into words here. So a few other words that we sometimes relate with inequalities, besides things like less than or greater than or not equal to, are words like at most or at least, must not exceed, must exceed. And those are still the same symbols we used above, but I'd like you to write down which symbols you think these are. So what do you think the symbol would be for at most, or the symbol for at least, or must not exceed? And I'm going to write a sentence here and see if you would agree with this statement here. Mr. Dixon is older. Actually, I should use a different word here for this, right? Mr. Dixon is at least I'm going to be generous to myself here. I'm going to say Mr. Dixon is at least 40 years old. I had a student tell me I was 80 once, and they were pretty sure they were true, they were accurate, but I just went home and cried that day. So Mr. Dixon is at least 40 years old. Okay, so let's say D is for Dixon. So I'm going to say D, and he's something about 40 here. Okay, so I'm looking at the word at least here. So this word here, at least. Okay. Well, does that mean I'm 40 and older, or does that mean I'm under 40? What do you guys think? Well, at least. Well, if I'm at least something, that means I'm that number or more. So that would be bigger than or equal to. So that would mean I'm bigger than or equal to that age. So the word at least means bigger than or equal to. Or maybe I should use the words above, greater than or equal to. Now, if someone said, I have at most $20. Do you when you see that word language, do you think that means that they have more than 20, or maybe less than 20, or maybe they can have 20? Well, if we think of maybe let's use the dollar sign here, okay, for money. That's how much money they have. So the amount of money they have is something to do with 20. So if they have at most that much, then they could have that much, but they could also have less than that amount. So we use the symbol less than or equal to. So this is less than or equal to. And another word, maybe not exceed, like you must, you're a bit young for this, but I'm sure you've seen this. You must not exceed 30 kilometers per hour in a school zone. Now, if you misinterpret that, you're going to get a ticket. So let's say your speed is S. So your speed is S. And let's just use the number 30 to represent 30 kilometers an hour. So you must not exceed that. So if you can't exceed it, can you go that speed? Well, if you exceed it, means you're more than that. So as long as you are less than or equal to, you would not exceed that speed. So must not exceed would be less than or equal to. Now, if you said something like, you must exceed, let's say you're working in a shopping mall or something, and you must exceed $500 per day. So you must sell that much stuff per day. So must exceed that much per day. Sorry. So let's use E, or let's say what you're selling. So we'll use S again for selling here. Okay, and then we've got this 500 here. So if you must exceed that amount, do you think that means you have to be more than that amount or less than that amount? Well, in the above question, we said not exceed was less than. So if you must exceed that, you must do better than that, which means you must do more. So that would, but not equal to, you must exceed it. You must be more than that number. So those are a few examples of how to interpret language in the question. So let's do one more example here where we're going to draw the solution here. So let's say that I said, I'm going to pick on, who should I pick on here? So I'm just thinking of my question first before I get too carried away here. How about Evie? I'm sure Evie's watching this. Evie is more than I mean, it's going to sound kind of silly here. I say more than 10 years old and at most 18 years old. And I'm going to draw this on a number line. So I'm going to ask you guys to draw this on a number line. So what would that look like if you drew that on a number line? So once again, you pause the video and see what you think here. Okay, so if I just drew the first statement on the number line, this would be Evie, so I'm going to use E here. Evie is more than 10 years old, okay? And so if I was to draw that, I could say, well, he can't be 10, so I use an open circle, but he could be more than, and I shade that way, okay? Now for the second statement, I'm saying that he is at most 18. So I put an 18 there. And now, because at most, what would that mean at most? So at most he can be is 18. So he must be less than or equal to 18. So would I use an open circle or a closed circle here? Well, I would use a closed circle. But now he has to be less than that number. So let's say I wanted to put this all in one number line, just not doing separate statements here, but just showing the understanding of the whole thing. Well, I know that he must be more than 10, but he must be less than 18. And I know he can't be 10, but he could be 18. So I'm going to shade this way for that and this way for that. And eventually what would happen is this would connect to there. So Evie is less than or equal to 18, but Evie is bigger than 10. So that's how we can put two statements on the same number line. So I just want to wrap this up here and say that if you have bigger than or less than symbols, you use an open dot, or you can think of it as a hole in it. And that's like this one right here, okay? And if you have bigger than equal to, less than equal to, then you use a closed dot, or I guess like I'm not sure, it looks like a period almost, I guess. And that's like this one right here, okay? So open sometimes, close sometimes, depending on whether you can be equal to those numbers. So I did have one more thing I wanted to show you, and I'm drawing a blank here what it was. Well, I'll put it in another video if need be. Yeah, so I understand some questions here. Actually, I'm gonna give you one more. Just this is a I should show you this actually. Sorry. So let's say you have a statement that's like 8 is bigger than x. Sometimes you'll solve questions and you'll have the x on the opposite side of the equation. And so what I would encourage you to do, and it really is preferred, is to have the x on the other side. Okay. So what I would encourage you to do is read the statement the other way, like read it from the right side to the left side. So if 8 is bigger than x, x must be less than 8. And so that would mean that you could be at 8. So you could not be at 8, but you could be any number that is less than 8. So just try one more here. Let's try 5 is bigger than or equal to, sorry, less than or equal to x. That's what that says. So you guys try that one on your own. I'm going to write another question below it. This is tricky. Tricky. Okay, so I'm going to rewrite this x on this side, put the 5 here. Now, if I'm saying x is, I read it backwards, it would be x is bigger than or equal to 5. So almost I kind of read it going that way. So it's kind of flipping that sign around. Okay, so this is definitely tricky, this last little bit here, and I'll probably do another video on this, but I just wanted to introduce it because there's like one or two questions in the homework that talks about this, but I want to do a better job in another video here. So I'm actually going to look at this one first, this statement first. I'm going to divide both sides by 2, or multiply by half. So I'm going to divide this by 2, divide this by 2, and I would get x, because 2 divided by 2 is 1, is bigger than 4 over 2, which is 2. And so that means that any number that is bigger than 2 should work for us. It should be good. So if I put 3 in, let's go back to the beginning here. So I'm going to plug numbers in for x, and you guys just tell me if you think it's true or false. Let's pick 3. 2 times 3. 2 times 3 is 6. 6 is bigger than 4. How about 4? Put 4 in for x. 2 times 4 is 8. 8 is bigger than 4. So this statement seems to be true. So any number you pick that's bigger than 2, it's going to work when you plug it in. So how would you do this question then? How would you solve this one over here? Well, to make the coefficient 1, you would times by the reciprocal of that, which would be negative a half. So we would times both sides by negative a half. Or in a question like this, you could just divide both sides by negative 2. And then something very strange happens now, okay? So negative 2 divided by negative 2 is x, or just 1x, bigger than. 4 divided by negative 2 is negative 2. Now, if I read that correctly, that says any number that is bigger than negative 2, open circle, bigger than negative 2 should work. And so I'm going to I did the questions before as sort of mental math, but let's try this. Let's pick a number to the right of negative 2. So I'm going to say let's make x 0, because that would work, or let's make x 1. So if I plug that into the equation, I get negative 2 times 0 is bigger than 4. Now, if I do negative 2 times 0, I get 0. 0 is bigoted. 0 is bigger than 4. Well, that is not true. That is false. That's weird. Let's put 1 in. Negative 2 times 1 is bigger than 4. So negative 2 is bigger than 4. Say, what? That's false. Okay, so there is something really strange that happens here, but I wanted to show you what would happen. Let's try this. Let's just rewrite that question. Negative 2x is bigger than 4. Now, instead of using the multiplication principle, the multiplication property, that is timesing by negative a half or dividing by negative 2, let's use the addition property. And what I'm going to do is I'm going to move my x's to the other side. So I'm going to add 2x to both sides. So that would give me 0 on this side is bigger than 4 plus 2x. And then what I'm going to do is I'm going to subtract 4 from both sides. So minus 4, and then I get negative 4 is bigger than 2x. And now let's divide both sides by 2. So that's going to give me negative 2 is bigger than x. Now let's rewrite this the other way, that is having the x on the left side. Well, that would be x is less than negative 2. So if I do it this way, I actually get a different answer here. I get negative 2, and I get open circle. But notice up here, we shade it to the right. Here, because we're less than, we're going to shade to the left. So let's see if that's true. Let's pick a number that's less than negative 2. So let's try x is equal to negative 3. Or maybe x is equal to negative, let's go negative 10. Let's go real crazy. Okay, so we have negative 2 multiplied by negative 3, and that's supposed to be less than negative 2. I'm sorry, less than 4. Sorry, I'm going back to the original question. Sorry, my bad. Less than 4. So a negative times a, oh, sorry, this, sorry guys. I'm looking at the original statement right here. I'm going to circle it, sorry. I'm looking at that statement. So I'm plugging numbers into that statement. So I should be using a bigger than symbol, bigger than negative 4. So negative 2 times negative 3 is 6, and 6 is bigger than 4. That's true. If I put negative 10 in, I'm going to get negative 2 times negative 10. And that's supposed to be bigger than 4. And so negative times negative is positive, so 20 is bigger than 4. So this statement is actually true, but this statement here up here is actually false. This is not true. But if you look at all the work I did here, I had to do a ton of work to get to that answer. That's brutal. So what I'm going to look at here is if I do this question up here, if I do it this way, which I think is the best way to do it, divide both sides by -2, what you have to remember is if you ever divide an inequality, that means like a bigger than or less than symbol, by a negative number, you have to flip the sign. So I'm just going to write that down here. So if you divide or multiply by a negative number, you must flip the inequality statement. Okay, so here's an example. Let's say you had negative 3x is bigger than or equal to, let's say, 18. Okay. Now, if I use the addition property, I don't make this mistake. It won't be a problem for me. But if I use the multiplication property, I'm going to create a problem for myself. So I'm going to divide both sides by -3. Okay. I divide by -3. So dividing by a negative makes it positive on the right side. So I get x. And then 18 divided by -3 is -6. So positive divided by a negative, sorry, yeah, positive divided by negative is a negative. But now I have to flip the inequality symbol. So I get that. So let's just test it to see if it's true. Like once again, you might be thinking this is like some kind of voodoo or something like that. Let's put -6 in, okay? So now I can be at -6, close circle, but anything less than should work. So just think of any number less than -6. So I'm gonna pick something not too big, but let's try -10. That's pretty far down there, -10. And what I do is I plug it back into the original statement and see if it's true. So -3 multiplied by -10 is supposed to be bigger than or equal to 18. Well, the negative times a negative is a positive, and so 3 times 10 is 30, and 30 is bigger than 18. So this actually is correct if you do it that way. If you had forgot to flip the symbol, then you would have gotten x is bigger than or equal to -6, which would be wrong, of course. But you could catch it if you just tried something. If you just tried to check this, you would right away see you're wrong. So pick a number bigger than -6. I'm going to pick 0. Okay. So I plug it back into the original statement. -3 times 0 is supposed to be bigger than or equal to 18. -3 times 0, or really any number times 0, is 0. And 0 is not bigger than 18 unless you're on some other planet or something. Okay. So that just makes me feel sad. Okay. So what I would know if I felt sad was I must have done something wrong. So I would go back and I would flip the inequality symbol. Okay. So this might be a really new thing for people. I think it's probably the only new thing in the unit. But maybe I'm wrong. Maybe you've never seen inequalities before. So I'm going to stop the video here. But just to recap, if it's a symbol like that or like this, we use open circle. Okay. And if it's like this or this, we use a closed circle. Okay. So open dot, close dot. And if we ever divide by a negative number, we flip the sign. Not if you add, not if you subtract, only if you multiply or divide by a negative, you flip the sign. Okay. And then the last one is just going over your words again. Do your revision of these words. So words like at most, at least, not exceed, must exceed. And then of course the big words, not equal to, and so on, and stuff like that. So I'm going to post some, where are we here? Ooh, that's bright. See the light. So I'm going to post some videos, questions on this, and this will be the last homework for the week. And so there's a little tab on your Google Classroom that says homework assignments, and you'll be uploading the homework for these 3 sections, which I think is 6.1, 6.2, 6.3. But just look on the tab, the homework tab, and it should say what is each homework lesson. Okay, so hope you guys are doing well, and we'll probably have another Zoom meeting next Tuesday, and I'll send out an email for that. Okay, so have a good night, guys.